Let's take a look at an example here of finding some local mins and maxes. So let's find local min and max if they exist for this function. Now we know that based on Fermat's theorem that the partials will be equal to 0. The partial with respect to x and the partial with respect to y will be equal to 0 at any of the critical points. Very similar to the idea we saw in Calc 1 when we have a function of one variable. So let's go ahead and find the partial with respect to x. Now the product rule, this is going to be e to the negative 2x squared minus 2y squared plus x times e to the negative 2x squared minus 2y squared times negative 4x. And I think I'm going to factor out the exponential function there. And this will give me e to the negative 2x squared minus 2y squared times 1 minus 4x squared. Now I need to set this equal to 0, and clearly the exponential function is never 0. So that would then imply that my critical values will be at x equals, that's going to be plus and minus 1/2. That's what's going to make this part 0. So I need to do the same thing or same approach with the partial with respect to y. And that's going to be x times e to negative 2x squared minus 2y squared times negative 4y. That will be 0 only when y is 0. So that tells me that my critical points are then going to be a negative 1/2, 0, and positive 1/2, 0. So I need to evaluate these critical points and figure out whether I have local mins or max. These are the candidates for extremes. Now, actually determining if these critical points are actually extremes or not is pretty difficult with this function. So we really need some other type of test. Now, remember way back in Calc 1, we used something called the second derivative test. That was nice for evaluating functions to figure out where local mins and max were. Basically taking or finding critical values and evaluating the second derivative at their critical values, and then that would tell us whether or not we actually had a local min or max. We're going to do the exact same thing here. We're going to use the second derivative test modified to fit this scenario. So that's what we'll take a look at in the next video, and then come back to this problem and actually finish this up.